Okay, so we still have people trickling in. Sean and Guillaume, if you could let them in as they arrive, that'd be great. I'll get started by welcoming everyone to the meeting. Good morning. Well, good morning for us in Canada. Good afternoon for those in Europe and elsewhere. This is our first ever webinar, so we're very happy to welcome you. My name is Lauren. I'm the marketing manager here at Tidal Robotics, and we are WindShape's exclusive distributor in North America, which is why we're hosting this webinar today. So the topic of today's presentation is how to improve UAV performance with a Windshaper. And your speakers are Guillaume Catry and Aurélien Balpin from WindShape and Charles Blouin from Tidal Robotics. So before we get started, I will tell you a bit about each of them. So first off, Guillaume obtained his master's degree in mechanical engineering and space technologies from the Swiss Federal Institute of Technology in Lausanne in 2015. He is co-inventor and principal designer of the Windshaper technology, which allows testing of drones in real flight conditions, including natural real wind, turbulence, gusts of wind, and other adverse weather or climatic effects. In 2016, Guillaume co-founded WindShape to develop and commercialize this technology, and his visions and ambitions are to address major technical and regulatory challenges of the drone industry by providing the best sets of tools and equipment for testing and developing drones. Aurélien holds a master's degree in fluid mechanics and energy engineering from the University of Applied Sciences in Western Switzerland. He has extensive experience with wind tunnel testing and flow measurement techniques, particularly for free-flying aircraft, including UAVs or drones. In the last few years, he has been involved with the development, manufacturing, and delivery of WindShape's facilities to worldwide customers, and has worked on the fundamental characterization of wind flow patterns generated by these novel wind facilities. Finally, Charles obtained a master's degree in mechanical engineering from the University of Ottawa, and his thesis was on optimal control of autonomous airships. During his master's studies, he developed the Series 1580 test stand in order to improve the flight time of an RC helicopter. In 2015, he graduated and commercialized the test stand technology by co-founding RC Benchmark, which has now been renamed Tidal Robotics. Tidal Robotics is now the industry leader in thrust measurement tools and software for UAVs, with the mission to provide drone designers with the best professional testing equipment for optimizing their propulsion systems. So improving drone performance is a common goal for our two companies, which is how we started to work together. So about 2 years ago, my colleague Geoffrey, who you see in the red shirt here, he met Guillaume, and they started discussing our different technologies. It turned out that while our tools were very different, they were both meant to help UAV builders enhance their design, allowing them to improve aerodynamics, flight time, payload, and handling. Geoffrey visited WindShape's facility in Switzerland and got to see how their technology worked and also how our technologies could fit together. Seeing our common goal, our companies created a partnership and have been working together ever since. In today's webinar, Guillaume and Aurélien will start by giving a presentation on how the WindShape technology works, including a short demo. Then Charles will talk about some practical considerations for motor and propeller testing with the WindShaper. Finally, we will end with a question session, so please put your questions in the chat throughout the presentations. I'll ask that anyone who isn't presenting turn off their cameras for now so we can conserve bandwidth, as we will be showing some videos. And on that note, I will hand the mic to Guillaume Catry, who will start us off.
Well, thank you very much, Lauren. Let me pull my slides up here. I guess you can see them now. Yeah, thank you very much, Lauren, for this great introduction and for organizing this first webinar. It's also the first time for me and for my team to that we participate in a webinar, and we're grateful to you for all your efforts in the organization of this event. So this part on WindShape will be split up in two parts. We're going to have a first 10 minutes or so for presenting the problem we're solving and the solution we have with WindShape. And I'm going to be presenting this first 10-minute session, and we're going to finish with an overview of the technology in this first part. And then before we hand it over to Aurélien for the second part of the presentation on WindShape, we're going to have a short demonstration with the demonstration setup we have here in this very room. So we're going to switch to a different mode here and show you how the setup works with a table configuration here. Okay, and then after in the second part, we'll see with Aurélien how the technology works, and we'll see some use case. So if you're a user of one of WindShape users, you might see your work being presented in this presentation. So we've selected some pieces of research that have been done with WindShape products. All right, so let's start with this first part, where I'm going to present you the problem that we're solving and the solution we have to help drones get to the market, and we do it by providing test solutions to the drone manufacturers and operators. So we see here a very nice drone. We're not making the drone, you know that. We are making the test conditions to test these drones, and I'm going to tell you here in this presentation why this is useful. So before we talk about the solution here, let me present you the problem that we're solving. We've done a survey of the industry, the drone industry, and we identified that every time a new drone needs to be brought to the market or needs to be validated, it requires about 5,000 flight tests to validate the drone. And if we put a number on it, if we say a flight is about $500, then it's a 2.5 million expense that you need to consider if you're a drone maker to validate your drone product. And then anytime you have a new feature to develop and to validate, it's another 300 to 500 flights that you need to conduct in order to validate the new feature. And that can be only just a software upgrade or something very that may appear to be very small, but still needs to be validated in flight. That's another $250,000 if we use the same metric. And what we also see by talking to the industry, and we all agree on that, and I'm very happy to talk about these two drone manufacturers that may be in this call today. The testing that are done and performed today are of poor quality. And this leads to low quality of results, long testing sessions for very small amount of data. So let's see how they are testing, how you're testing if you're a drone manufacturer. So most of the drone manufacturers pick the outdoor testing as the first choice. Of course, it might seem to be very cheap and affordable to do that. But the problem with this is that it's not repeatable. So it means that the weather will change between one test and the other, and the tests that you're doing today are not going to be repeatable tomorrow. So you're not able to obtain the same result from the same test. That's a big problem. And the other problem is that you cannot control the test conditions. If you need to test your drone, say in a given wind condition, in gusts or in weather with rain or stuff like that, well, it's not possible to ask weather to change, right? So you have to travel far or just to wait for the weather to change. And the last point here is that when you're flying outside with a drone, it's very hard to collect data. So it means that you're sitting on the ground, your drone is at hundreds of meters from you, performing the flight test, and you're unable to first capture the meteorological conditions that are at the drone when it's flying, and you're unable to monitor the drone behavior with sensors because the drone is very far from you. So big problems here. Another solution that is available to drone manufacturers is to use wind tunnels. Well, wind tunnels are great for aircraft, great for cars. They've been used for hundreds of years, for 400 years for testing these crafts. Problem is they are not representative for the drone environment. So it's not possible in there to make variable winds and the type of wind that your drones will experience when they're flying in a city center, for example. The other point is it's high cost to test in a wind tunnel like that, because those infrastructures are big, huge, if I may say, and the costs are extremely high. And last point is, when you're testing in a wind tunnel, you're in a confined space. The drone is attached to a support, which means that you're not able to do free flight testing. That's another big point. So if you want to do free flight testing in controlled conditions, you can use a leaf blower, and at least that's what they do at Skydio. And it's not a unique example. I've seen many drone manufacturers using leaf blowers or fans to test drones with wind perturbations. Well, to me, this demonstrates, well, creativity first, but also a lack of reliable test solutions for these drone manufacturers. And this is why where we get the motivation to develop solutions for testing drones in free flight, in any weather, in a trustable lab environment, in repeatable conditions, with a true GPS signal that we can create in the lab, and in a way that makes it possible to collect test data non-intrusively. So that's the requirements for the ideal test center for drones. Now, a little bit more about the motivation here. What I'm going to show you here is the parallel that we can make between a drone that is experiencing weather or flight conditions outdoor in a real flight, and a drone that is being tested in a WindShape environment. And you can see from this animation that our goal is really to be able to repeat and recreate every step of a mission of a drone, including here loading a payload, descent, ascent. It can be also flying in weather, as you can see now in this animation. So our goal is really to be able to recreate the full environment of the drone, but inside the laboratory where we can control the conditions and make the test repeatable. That's a very big point here. So some of the most important things to test for a drone. So if you're let's say you're a drone maker and you're making drones for delivery, flying in between buildings, that's going to be a big problem to validate drones in these urban environments. So that's another great reasons for having a lab environment that makes it possible to generate variable winds, shear flows, and gusts, and etc. So this is why we came up with this idea of the Windshaper. You can see it from this picture on the top left. You have a screen of fans. You see here about 1,000 fan, and that's the flight environment. So it's here a 3 meter by 2 meter screens of fans, and we call these fan wind pixels, by the way. And by controlling the wind pixels independently from each other, you can generate pretty much any flight condition you need to validate the drones. You can see from this slide as well that we have our own proprietary software to control the Windshaper, and we also have a combination of technologies. First point there on the top right, we use motion tracking cameras to capture the attitude and the position of the drone during the flight, and that's a non-intrusive way of measuring the behavior of the drones during the test. Another point that wasn't mentioned yet, the third point on the right here, the GPS simulator. We have the capability in the test area to generate a GPS signal to make the drone believe it's flying a mission. So we can make the drone think it's flying outdoor for real, while it's actually in the lab experiencing a test scenario that we simply created for him. And we're showing this in a video, so you can see the fan array that it's a pretty big fan array here. We have an operator that is bringing a module in the Windshaper, and we're going to talk a little bit more about the modularity just in a few slides. You see here the wind pixels that are turning on, and the whole point of this video here is to show you that we can test all types of drones in a Windshaper environment, including multicopters and fixed wings. So you can see here a very nice flight from a SenseFly EB drone in the Voliro multi-purpose flying robot. And you can see they're flying the test environment under the eyes of the motion tracking cameras that are attached to the walls and collecting data from their flights. Yeah, more about the modularity here. As you can see from these three pictures, the core technology of WindShape is these modules, and this is what comes out of our production line, these modules. And thanks to those modules that we can stack together next to each other, we can generate and make pretty much any configuration of a Windshaper. It can be a small, tiny, medium size, etc. All of them are based on the same module. So you can see that one module is made of 9 wind pixels, and each wind pixel is made of 2 fans that are counter-rotating. And the goal of these counter-rotating fans is that they bring a very good benefit in the way, in the sense that the wind that comes out of a wind pixel is we were able to remove the swerve from the wind thanks to the counter-rotating effects of the two fans, and we have a very clean flow at the outlet of the fans. Now, a few examples of configuration that we can make with this module. So we can see from the top left, the tiny 2x2. We're talking always in modules at WindShape, so 2x2 modules. This is the tiny configuration that I have just behind me in this room. We're going to give you a demonstration of this small Windshaper here in a couple of minutes. We have a small Windshaper, the 6x3, approximately 1.5 meter by 75 centimeter in height. Very convenient. It's on wheels, so you can move it in the lab, remove it from the lab if you need free space, for example. On the top right, you see medium configuration with 8x7 modules, about 500 wind pixels, 2 meter by 2 meter, almost. And one thing I need to say about all these Windshapers, that the wind speed that we can generate at the exit of the fan is 16 meters per second. And then you have a large configuration, 12 by 12 modules that I'm going to present in this other slide here. It's the facility that is currently sitting at Caltech at the CAST lab, a very advanced lab for drones, and you can see that they have a nice feature as well on the bottom left of the screen. They have the tilting system that makes it possible for them to pivot the wall from 0 to 90 degrees. And this is an option that can be assembled in any Windshaper. All right, now a few words about the control interface that we have. So we have any computer that is connected to the Windshaper with an Ethernet cable can access a graphical user interface that is available as a web application. So you simply connect your computer to the server of the Windshaper, as simple as plugging a cable, and then you type the address of the web app in your favorite navigator, and you'll get and access this page where you can simply click and select fans and run them at the speed you want. And this is really as simple as it sounds. Really, it's a nice and easy way to control the fans. And then we have a Python API. This is a more advanced control interface for people who wants to do some research maybe, or use sensors in the test area. For example, if you have sensors to measure wind speed, then you can loop the sensors with the Windshaper and create your own regulation. Well, there are many things that you can do, and I should also mention that you can run some mathematical functions directly on the fan, so you can use any function you want, and we're going to give you a demonstration of that in a couple of minutes. I'm almost done with my first part. Almost last slide here. I'm going to show you that we're providing this solution in two configurations. One is we sell this equipment, so you can, if you're a university research center, this is typically what we do. We sell the equipment for your labs. The product is totally ready, developed, industrialized, and certified, so you can get it starting today. And we also have testing services, so you can see all the pictures you have on the right there. Testing in weather, testing in rain, etc. This is something that is not commercially ready to sell as a product, but you can get it as a service. So if you're interested to test and validate your drones in weather, feel free to contact us. And by the way, contacting us, you can contact Geoffrey Ferry at titlerobotics.com. You have his email address at the bottom of this slide, and Geoffrey will let you know. We'll let people know in our company if there's a specific question that comes up. All right, and my last slide here is where I tell you that there's more than just testing in this industry. There's a lot of things that needs to be done to close the gap and bridge the gap between the great product that we see in the industry right now and flying drones, validated and flying drones. And so we are all dreaming about real drone applications. So before we can get there, we think that there's a big regulatory step that needs to be taken, and this goes, this needs to be addressed by professionals. So we we teamed up with Safely and DigiSky. It's a group of companies that is called ASEL, and this stands for Aerial Systems Compliance Laboratories. And there we can provide you with a regulatory strategy, CE marking, testing, safety certification, etc. All right, so now it's time for a quick demonstration. I'll invite Aurélien to join me in this room. What you're seeing here is the setup is Aurélien sitting behind the computer there. We have a screen that presents you the web application that we use to control the fans. And we see here a small 2x2 module Windshaper. And we have a little marker here to show you when the fans are running, because obviously you cannot see wind, right? Okay, Aurélien, can you maybe show us the web interface? So yeah, what we're seeing here is that Aurélien is able to select fans by clicking on them. As I said before, it's as simple as it sounds, and they can set up the wind speed, typing here the power from 0 to 100%. It just typed 10%. I'm sure you cannot read it, so I'm really reading it myself. This is 10% of the speed, and you see that we have some wind there, so you can also hear that the wind speed is increasing quite quickly. It's one good reason for using Windshapers, because they are very reactive. So you can change the wind speed very quickly, and that's not something you can get in a conventional wind tunnel normally, because there's a lot of inertia in the air, and also in the moving parts, the fans and all. They are hard to accelerate. All right, so maybe Aurélien, can you show us the functionality where we can type a wind function? Okay, you just copy pasted a function that you prepared before, and the function is 20 plus 20 times sine of 3xt. For those who talked this language. For those of you who talk this language, so we'll see what it gets, what it gives. All right, so you can see from this screen, and you can also hear that the fans are responding to the function that Aurélien just typed in the graphical user interface there. And it's a pretty funny function that you typed there, Aurélien. All right, so thank you. That's it, I think, for now. We're happy to come back to this setup with your questions later. And by the way, feel free to type your questions in the chat if you have questions, because we're going to take a moment at the end of the presentation session today to answer your questions. All right, Aurélien, the floor is yours. Have fun.
Thank you. So hello, everyone. After this short presentation, I'm going to talk a little bit about the different methods and tools you can use with the Windshaper. So we will then look at different examples, different use case that were conducted by our customers. And I tried to focus a bit on technologies and uses that are different from the drone industry, to give you an idea of the wide variety of uses you can do with the Windshaper that might not be straightforward when you look at it at first sight. So to start, you need to know that there are two main ways we can use a Windshaper. So the first one is basically to use it the way we've been doing aerodynamic studies for the past 100 years or so. So the idea is to have your model, the thing you want to be tested, attached at the center of the test section, and then you will simply have low turbulence flow on it, and you will measure the forces to get the flight performance. And this can be easily achieved with a Windshaper, notably by using some flow filters. But we can also do another type of testing called free flight tests. And the idea here is to basically let the drone fly freely and to not try to get the lowest possible turbulence level, but to get turbulence levels that are realistic. If you look at outside wind, we are between 10 and 30% of turbulence, and we can reproduce this with a WindShaper. And then you can measure the position of the drone or your model you want to be tested using optical tracking. So if we look at traditional tests, wait. Okay, sorry, it's just, yes, okay. So the traditional methods, as I said, we can use some flow filters. So you can see it on the left side. We can also use some converging ducts to accelerate the flow. And we can also combine the two to get what we call aeronautic flow quality. So really, really low turbulence level and quite high speed and high homogeneity in the flow. And so if you look on the right, this is typical traditional tests used using a WindShaper. So you can see airplane model tested with flow visualization and a sting balance to measure the forces. And the innovative tools we can use are, as I said, optical tracking. So on the left side, you can see how the drone is optically tracked using motion capture system. And we can also use the same motion capture system to make flow measurements as seen on the right. So this is a system developed by the Swiss company Streamwise called ProCap. And you can basically measure the flow in real time and then see it basically like you would see CFD results, except this is not a CFD simulation, this is real measurements in 3 dimensions. So this is an example of what you can do integrating all those solutions together. So you can see a multi-copter drone flying in front of the WindShaper, and all the data is automatically logged into your computer. So all the information about the wind, about the drone, attitude, performances are all logged in real time. Now, as I said previously, we can also replicate real winds. So the way we did this is basically we took some measurements outside here in Geneva during some windy days. And we used some hot wire probes. So for those of you who are not familiar with, it's a type of aeronautic probes that are used to measure really precisely the flow and the turbulence inside a wind flow. So we then used some control algorithm to reproduce this in our WindShaper. And if we quickly look at the data, you can see on the left side that not only are we able to reproduce the wind fluctuation with time, we are also able to reproduce on the right side the turbulence spectrum. So the different vortices that you will see inside the turbulence, the different scales of the turbulence are quite well reproduced. So you see the yellow line is basically what you get in the normal outdoor wind. The blue line is standard WindShaper, and the reproduction is the red line. So we can see that we are very close in both the time history and the turbulence spectrum. So not only are we able to reproduce the wind, we are also able to reproduce the rain and the snow, which are both very important for drone use and certification in all weather. Furthermore, we are also able to reproduce icing conditions, which again is very crucial for drones all-weather certification purposes. So for this, we use the WindShaper inside a large climatic test chamber, and we can then create some misty wind, we would say, at very specific conditions of humidity and temperature to reproduce these icing conditions.
We try to do is that to let every turbine in a wind farm work together. In that way, we can produce
we'll
more
look at
energy
some
out of a wind
use case.
farm
I don't know if
and
there's
also
some
distribute the structural loading over the different turbines.
noise. Sorry. Okay, sorry about that. So we'll then look at some use cases. So this is 2 use cases in the wind energy department. So on the left side, you will see at TU Delft in the Netherlands, they are using a Windshaper to study wind farms and how, when you have several wind turbines in front of the other, how they will affect the flow of each wind turbine. And they use the Windshaper to reproduce accurately some atmospheric winds and atmospheric boundary layers. On the right, you also see kind of the same setup in Switzerland at the University of Applied Sciences. The idea is to improve efficiency of wind turbines by having some aerodynamic oscillators. So wind energy is one use case. The automotive industry is another interesting one. So you see here some F1 cornering aerodynamics that were also done in Geneva at Flavio Noca's lab. So the idea was to study a bit more the aerodynamics in corners, because we know a lot about the aerodynamic of Formula One in a straight line, but actually they spend most of the time in the corners. So the idea was to use the Windshaper with the vane that was curved to replicate this rotating apparent wind. And you can see on the bottom 2 images, they are also using the ProCap system to get the measurements of the wake behind the tires. Now, we've seen some models, but we can also do some full-scale testing in a Windshaper. Because we don't have any walls around the test section, it is easy to put some big models like a full-scale cyclist or a car, and to test it in a simple way. This is another funny and not intuitive, I would say, use of a Windshaper. So in this case, this is Princeton University at Campbell Staton Group. They are studying how the lizards are adapting to urban areas and also climatic change, and more specifically, how they can resist to hurricanes. And they do that by using our Windshapers to basically blow on the lizards and see how they can attach themselves to objects, which is quite interesting. And finally, my last use case, which is, yes, it is a drone, but it's a drone flying on other planets. So I think it's interesting to put it here. You have to know that the Mars helicopter Ingenuity, that's been flying for the past, 2 years, I think now, on Mars, has been previously tested using our WindPixel technology at the California Institute of Technology in the USA. And so this is another really interesting thing that people don't think about. But as you can see on the top video, there's some wind in Mars, and we need to reproduce not only the wind on Earth, but we can also do it with the wind on Mars. So I thank you for your attention. If you have any question, please write it down and we will answer it later. I will now hand it over to Charles, who will present some propeller testing in wind tunnels.
Thank you very much. So as we talked earlier, I'm Charles. I'm the president of Taito Robotics. We're the world leader in manufacturing of propulsion testing equipment, or specifically electric propulsion testing equipment. And we've been operating since 2015. As the year has gone by, we've manufactured larger and larger tools. And very recently, we've released a new generation of propulsion testing tools, which is a complete redesign based on everything we've learned in the last 7 or so years. Today, I'm going to talk about specifically propeller and motor testing in a wind tunnel context. However, before I do that, I just have to talk a little bit about why test your motors and propellers. Overwhelmingly, the largest and main use case we see is to improve performance, so flight time, payload, and range. I'll come back a little bit later to talk about that, and I'll explain exactly how the measurements can help you increase your flight time and payload. Something important too is motor thermal testing. This is an important factor in failure in flight. It's often a thermal damage and can cause electronics failure. We're also seeing more noise and vibration testing, especially for flights in urban environment. There's also flight replication, sometimes for certification, and also with our tools and the high-speed measurements that we have, it's possible to do things like throttle response or any kind of dynamic response, which is especially useful for modeling the motors and propellers and then using them in simulation later. Talking about simulation, having accurate thrust and torque data is also very useful in the structural design of the vehicle. More recently, we're also seeing more tests that are done for safety, especially reliability, certification, or flight icing, as we've talked about a little bit earlier in the presentation. And we're also seeing more uses now for production and operations. So that means testing the motor and propeller on the production line for quality assurance, and also further down the line during operations for preventative maintenance and diagnostics. I'll talk a bit about tests specifically of motors and propellers in a wind tunnel. The first and most obvious test is to test the thrust as a function of rotation speed and wind speed. Obviously, the thrust is going to be heavily dependent on the wind speed. This is why you'll have different shapes, different geometry, different pitch of propellers. Something a little bit less obvious is when you're flying any kind of vertical and takeoff drones or any kind of acrobatic fixed wing, you're going to have some side winds. And this is going to affect the thrust that you get. So that's also another kind of test. You can tilt the propeller and you're going to obtain different measurements based on this different geometry. Another thing that's particularly important is thermal testing. When you buy an ESC or when you buy a motor, you're often going to get a current rating. This current rating is actually based on the thermal rating of the motor or the ESC. And that thermal rating is heavily dependent on the air temperature and the kind of cooling that you get. And the most obvious and the easiest way to test the cooling is to test it experimentally. So that's why our tools have temperature measurements. You can measure the air temperature, you can measure your component temperature, and then based on the delta of temperature that you get, and also based on the type of magnets and coils that you have, you can establish a safe operating temperature and safe operating condition for your vehicle. And finally, another important test is the effect of coaxial testing, or more generally, what effect multiple powertrains have on each other. So when you have two propellers that are close to each other or one behind another, there's going to be some kind of effect, and that can be tested with different wind conditions. So talking about different kind of test configuration, most often you're going to see some back-to-back testing. On the left, that's to improve thrust generally. You can also have face-to-face or all kinds of different combination of offset, so radial or actual offset. You can also see different speeds that are used for the front and the back propeller that can give you different sound characteristics, or you can also have the same thing with different size of propellers. In general, a question we get is, what is important to measure? Obviously, you'll have torque, thrust, RPM, current, and wind speed. I want to emphasize how important torque measurement here is here. And this is because with torque measurement, you're able to obtain things like the mechanical efficiency of the vehicle. You can obtain mechanical efficiency because with torque and RPM, you get mechanical power. And then with voltage and current, you get electrical power. When you have a ratio of both, you know how efficient your motor is at taking in electrical energy and getting mechanical energy out. You can also do, in wind tunnel, you can do tests like forward flight efficiency. I'll come back to that a bit later. And also the effect on reaction time and the flight dynamics. I mentioned forward flight efficiency. This is something that's specific to testing in wind tunnels. And it's a type of measurement that allows you to know how efficient is your vehicle at taking in either mechanical or electrical energy and converting it to forward power. So when your vehicle is moving forward in the air, it has a certain velocity, and it also has a certain force from wind resistance. And when you have a force and a speed, that's the definition of power. So That's the idea of what forward flight efficiency is, that you obtain certain mechanical energy from your motor, and how efficient is your vehicle or your propulsion system at transforming that mechanical energy into forward flight. Now, obviously, that's a lot of data to test and analyze. You have different wind speed, you have different angles, you have different airframes that are possible. So how do you make sense of that, and where to start? We're typically going to suggest to start with a good propeller selection. You can test different diameters, different airspeed, different geometry, and based on the required thrust and the required performance, you're typically going to be able to narrow down to a few types of propeller geometry. From there on, you'll know what kind of torque and RPM you need, and that will help you do a good motor selection. Once you've done that loop a few times, it's only then that we suggest to move on to the optimization of the electronic speed controller, or the motor controller. And typically that can get you an extra 5 to 10% efficiency. And finally, we have to remember that all of that optimization loop is within a bigger optimization loop, which can include the battery, so the size of the battery, the type of battery we have, as well as the airframe. I want to talk about some practical consideration when testing in wind tunnels and using a motor and propeller test. First of all, you have to consider the aerodynamic effect of the tool itself. You'll want to have something that's compact to minimize the effect, and you also want to measure and calibrate the effect of the tool. That can be done by testing with the motor installed, going at 0 RPM and testing at various airspeed. That's going to give you a baseline. But calibration can help, but again, it's also important to consider the geometry of the tool. Finally, I'd like to talk about some important characteristic when choosing a thrust stand, and that's something we've taught a lot about. Again, first of all, I want to emphasize torque measurement. This is, if you don't have torque measurement, you're only measuring the electrical input and the thrust, and it's kind of a black box optimization. But when you have torque, you can know your mechanical power, and it really speeds up the analysis and the design process. Something to consider also is the calibration and reliability of your tools. Testing is very expensive. It takes a lot of time to get the environment set up, have the time to from the engineering time to set up the test. So we don't want to be in a situation where after a month or two of tests, you realize that you have some friction in your tools or some kind of hysteresis that makes it that a lot of your data is unreliable. Something that we found that really helps with reliable data is to have in general solid state systems for force measurement. So that means that trying to avoid things like bearings or pivots, they really tend to seize up and cause issues. That's why we've moved away quite early on from those kinds of systems. And you'll also want to have cross measurement rejection. That's particularly important in wind tunnel, because if you're testing with side winds, you're going to have side forces, and you don't want to measure a side force as being a thrust or a torque. Also, we've noticed over the years that a lot of data is being generated when doing tests. You'll have many combinations, and you'll want a software that's able to generate that data repeatedly. That's partly why we've implemented automatic features. And you also want to have a software that's able to help you document and keep track of your experiments. Another important point to consider is safety. If you're doing any kind of tests with operators around, with wind tunnel, with cameras, it's a very expensive environment. So you want to make sure that you won't have a failure from your own equipment. And if you do, you also want to make sure you're in an enclosed space. And finally, for any kind of tool, you'll want to consider compact design. We've seen time and time again that having geometry or having an object in the room will affect thrust. It could be a physical object like the wall, or it can be physically the tool itself. And this is why we've worked very, very hard to make a tool that's as compact as possible and that has all the sensors in a very compact environment for your test. So with that, that concludes my part of the presentation on testing of motors and propellers in wind tunnel. I'll pass it back to Lauren.
Okay, thank you very much, Charles. So at this point, we've set aside some time for some questions. So if anyone has any questions, feel free to put them in the chat. After today's presentation, we're going to send out a survey for feedback. So if you have anything to say, you can also let us know there. or if you want to get a head start and contact us outright, as Guillaume said earlier, you can contact Geoffrey Ferry. Okay, perfect. What kind of hurricane wind speed can you achieve with the Windshaper? What would be the limiting factor to increase wind speed? I think that one's for Guillaume.
Yeah, yeah. Well, thank you, Dominic. Yeah, the limiting factor is first of all the speed itself. We can make 16 meters per second at the exit of the fan. If we want to increase the speed beyond this number, we need to add a contraction in front of the fan array so that we can bring all the flow to a smaller hole so that we can increase the flow speed. But beyond that, there's a limit that is very high. I think 50 to 60 meters per second if we use a convergent. But that definitely increases also the size of the Windshaper in proportion to the size of the test section. So if you want to increase the wind speed, you need more fans and you need a contraction to reduce the test section to a smaller size. But without using a contraction, yeah, the maximum speed is 16 meters per second, which is already quite high. And if you experience some wind in a windy day, especially here in Geneva in Switzerland where we are, 16 meters per second, which is roughly 60 kilometers an hour. This is already a lot of wind. We don't have that so often in Geneva. So, and the other thing that we can generate is the variation in wind. So it's not necessarily only the wind speed itself that is posing problems to the drones or stuff. The problem is the variation. So if you have a sudden increase in wind speed, this is what will offer a larger perturbation to your drone than just wind speed. Anything to add, maybe, Aurélien?
No, I think it's clear.
Okay, fantastic. Thank you, guys. Our next question, I believe, is for Charles. What calibration process do you use to provide reliable measurements?
So for the pro version of our tools, we use an ASTM process, but all of our tools we build basically a special machine that allows us to apply forces and torques in every possible directions. This allows us to do calibration, but also to check and to calibrate for any kind of crosstalk. It's a big part of our technology and just in general how we do the calibration.
Okay, we have another question for Charles from Rami, who asks, do you have a thrust stand that is able to provide data for a propulsion system that has thrust vectoring capabilities?
So I'd encourage you to contact us about that. Commercially right now, we're offering torque and thrust measurement, but we're looking into the possibility of offering potentially more access of measurements, but it's not in the very short term. And I'd suggest we discuss together and look at what's possible to do for your specific application.
Okay, next I have 2 questions for the WindShape team. Could it work as a training space for FPV racing? And what about building facade inspection using a DJI drone?
So first, the building facade, actually, if you've seen the video at the beginning of Guillaume's presentation, we've seen the Volero drone flying, and this drone is used for building facades inspections and painting. So this is already something we do. I don't know if you want to add something about that part.
Yeah, no, that's correct. That's one of the goal of this drone is to do inspection near facades. And yeah, the great thing about having an open test section is that you can bring some elements in there, some passive elements. It can be a wall or something like that. So it means that you can recreate the inspection scenario in the test chamber by bringing just a wall in there and simulating the interface between the drone and the wall. So that's something we can do. And the other question, I think, was related to training FPV pilots. Is that correct?
Racing pilots.
Racing pilots. Yeah, I don't see why not. We thought about using Windshapers to make obstacles for the drone races, for example. So that was one of the use cases we had in our minds a couple of years ago. We never went through with that, but it's still interesting to consider. Now, training directly, I mean, it is challenging for a pilot to fly in a perturbated environment, but I'm not sure which extent we could use it for training pilots. We've never done that, so that's to be thought about, I would say.
Okay, another question for you guys. Do you have a recommendation for what Windshaper size to use for which use cases? That's from Newman.
Yeah, usually the configuration of a Windshaper depends on well, different factors. One is budget is always a big factor in the configuration of a Windshaper. Then there's the size of the room that is available. We cannot install a Windshaper is too big for the room. So we have some guidelines to help people design the best Windshaper for a given room. And then there's the problem of the power that is available. I mean, it's a wind tunnel. It needs power. So if there's not enough power in the room or in the building, that's another limitation that can be that can limit the size of the Windshaper. But beyond these three factors, normally there's nothing that limits us to make a Windshaper the size we want. And then after I think it really depends on a case by case, but we like to have a Windshaper is bigger than the test subject, so it really depends what we want to do. But yeah, we are happy to talk about this in a private call. If there's a specific project to talk about, we're happy to do that. Yeah. Okay, fantastic. The next question comes from Mahavishnu. I think this might be a question for both teams. He says, as this test bed is very useful to multi-rotors, but can we use it for bigger fixed wing models in static conditions? How close will the results be compared to a conventional wind tunnel? You want to take it or?
Yeah. Yes, so we can use it for fixed wings in a static condition. Maybe if we remember at the beginning of my presentation, I showed you that there are two different ways you can use a Windshaper. So one way is to let the drone fly, and the other one is to have it like a conventional wind tunnel attached to a balance or to a support. And if we use flow filters on the Windshaper, we can get below 1% of turbulence intensity, which is already quite good for a conventional wind tunnel. And if we use a converging duct after the flow filter, we can also increase both the speed and the turbulence, I mean, reduce the turbulence. And then we can go below like 0.2, 0.1% turbulence, which is really like excellent. Most wind tunnels cannot go that low in a turbulence intensity. So you will get some really good results using balances, force measurements. It's as good as a conventional wind tunnel, I would say, with the added benefit that you can then use the different fans to generate more turbulence if you want, or you can simply use your Windshaper for other applications. That would be like letting the drone fly by itself. So I don't know if that answers the question.
Charles, did you have anything to add, or does that cover it?
No, I think that covers it. For bigger tools, actually, for us, it's really more about the size of truss stands that's available, and we're working on larger tools.
Fantastic. We have a question from Carlo. I'm not sure who it's for, but he says, do you have a commercial reference in Italy?
We'll contact you specifically for that after the meeting. So.
Okay, fantastic. That's all the questions I see. Oh, we have another message. Oh, just thank you. If I missed anyone, just drop me another note. Otherwise, I think we've covered all the questions.
Great questions, by the way, and thank you all participants for attending to this webinar. It was great seeing almost 40 people, I think, at some point. So yeah, great attendance. Thank you very much for joining today.